Classwork contemplations. Here we go. What are we going to learn about today? Well, the first thing we're going to learn about is what we call the rule of 72. This is something very important to know about when it comes to estimating where your money might be down the line, which for a teaching career is something you ought to think about very much. Okay, so what does the rule of 72 say? It says if you take the number 72 and you divide it by the interest rate, then it's going to tell you how long it takes to double. So for instance, if you said my interest rate is 8%, it'll take you 9 years because 72 divided by 8 is 9. 9 years to double your money. But it also works the other way around. If you do 72 divided by 9 years, you get 8% is the interest rate that you had to have to get that. So you either divide by the interest rate and get the time, or you divide by the time and you get the interest rate. Pretty straightforward. This is nothing complicated. Let's do one question at a time. And let me show you the first one. Ready? $4,000. It says Jared owes $2,000 on a credit card that charges him an annual percentage rate of 18%. If Jared stopped making payments, how long would it be before the balance on his credit card reached $4,000? And what you notice is that $4,000 is double $2,000. So what they're really asking is how long until it doubles. So since we're talking about doubling and compound interest, because the rule of 72 only applies to compound interest, I do 72 divided by 18, and I get 4, so it'll take 4 years. You try number 4, stop and start. Pardon me, I got the hiccups. Okay, so, and this is a true statement, when you miss payments with a credit card, they up your interest rate. So now they juice it up to 24%. Thieves they are. 72 divided by 24 is 3, so in 3 years, your money would double. Emily gets a new job, guarantees her 6% raise every year. If she starts out making $25,000, how long before she doubles her current salary? Stop and start. Okay, so again, it's 72 divided by the interest rate. So if I do 72 divided by 6, in 12 years her salary will double. That's pretty good. 6% raise every year is pretty good, that's for sure. Okay, number 6, if you invested $250 at 16%, how much money would you have after 18 years? Let's have you try that one, and then I'll take you through it. It's actually 2 steps to getting that answer. Okay, sorry for the yawn here. 72 divided by 16 is 4.5 years. So every 4.5 years, it's going to double. And what I notice is that if I do 4 times 4.5, I get 18. You might have looked at it as 2 4.5s make 9, and then I got to double that again to get 18. So basically, here's the table. If you have $250 the first at the start, then 4.5 years later you have 500. 4.5 years later you have 1,000 because you're doubling it every time. 4.5 years later you have 2,000, and 4.5 years later, which is the year 18, you have $4,000. Okay, Ron and Amy opened an educational savings account for their daughter when she was born. Very responsible parents there. I wish I'd have done that for my kids. Making a $5,000 initial investment. They were unable to ever add anything else to the account. What was the rate of return if they had $10,000 after 12 years? Well, stop and start, you know the drill. It's going to be, you can divide by the time and tell you the percent, so it is 6%. Okay, so that's an idea of the rule of 72 and how to work with that. Now let's start talking about the investments that you might apply to the rule of 72. Now, there are many different types of investments. There are things called annuities, savings, like savings accounts and stuff, CDs, money markets. There are bonds, there are stocks, and there is, of course, real estate. Real estate is very much an investment. So those are our investment options, things that we can do. So let's give you some definitions here. An annuity is any series of equal regular payments. So I have an annuity set up, and at a certain age, I'll be receiving a certain amount of money every single month from this annuity. And then the annuity is set to run out when I would hit a particular age. My grandfather had an annuity that he didn't even start collecting from until he was well into his 90s. So you don't even have to start taking money from them right away. Now, an ordinary annuity is a savings plan in which payments are made at the end of each and every month. An annuity due plan is a plan where payments are made at the beginning of each period. And you know what? They also have it where you can just give money. Like the way my grandfather did it is he took like, I don't know, whatever, $100,000. It was a good amount of money. And he put it into this, it was Jackson fund. It was a Jackson annuity. He just said, look, I got this money. I don't need it. So he put it in the annuity. And it was really wise planning because there was lots of money left in it when he passed. And it went to his daughter and my mom. Okay. So annuities pay out regularly over time. A future value is the accumulated amount at some future date. Okay. So if you're earning a certain percent interest and you deposit a certain amount, they do the calculation and they say, okay, in the year 2040, it'll be worth this amount of money, and then you can start collecting. Present value is what it's worth on that particular day, okay? Present value of a savings plan is a lump sum deposit that would give the same end result as the regular payments into the plan, okay? Now, there is a savings plan formula, and right about now, you're probably looking at this like, you want to scream. I mean, this is pretty ugly. But it's not so bad. We're going to work our way through it. A is equal to the accumulated balance after Y years. So it's the amount of money in the account. Y is the number of years. PMT is the regular payment deposit amount. So it's the amount that you're going to put in every single month, or as often as it's going to be. It could be every year. APR is the annual percentage rate, always as a decimal. N is the number of pay periods per year. So like, a lot of them are 12. You put it in every month, but it could be biweekly, so it could be 26. And we said Y is the number of years. So use the savings plan formula to find the balance after 1 year with an APR of 12% and monthly payments of $100. So notice what we got here. The formula's up top, and in place of the payment, it's how much you put in a month, which is $100 a month. And then all it's a matter of doing is just plugging in the numbers where they go. In the formula, 1 plus, and then it's just the rate divided by the number of times. So 0.12 is the rate divided by 12. Cute how they chose such a convenient number. And then the exponent you raise it to is the number of payments in a year times the number of years. And we're doing 1 year. So 12 times in a year, 1 year. Just like with our other formulas for compound interest, these 12s are always going to match. And then you subtract 1 from it over the annual percentage rate divided by n. So that's 0.12 divided by 12. So you'll notice that these two things match here. So yours should match as well. So then I plug it in, a couple of quick signs. Yep, they match. Okay, I got everything looking good here. So then I just do some work on the calculator. In the numerator, I get 0.1268. In the denominator, I get 0.01. So I multiply it all out and I get $1,268. And that kind of makes sense because, if you plug in $100 a month, you'd have $1,200 and you're going to earn some interest over the course of the year. And in the beginning of the year, there's not going to be much interest because there's not much money in the account. But by the end of the year, you'll start earning a little interest. So $1,268. Okay. Let's see you do it this time, but the balance of $250. See if you can track through. I'm going to pause for a second. You track through and see if you can follow this work here and come up with the same number on your own. Okay, so as you crunch through, this time the payment is $250. And it's the same thing with the 12% and the divided by 12, but this time it's 2 years. So a 2 has to go up here, minus 1. And 250 times, and this is just crunching the numbers here, it works out to $6,743.36. Again, that seems reasonable because $250 a month times 24 months works out to be $6,000, and then you get interest on top of that. So yes, the numbers seem reasonable. For the last two questions, if for some reason you did not understand how to use the formula, two things. Number one, this is a formula I would take a picture of and save in my file in my phone. The second thing is go through and do it again, just working your way through the numbers. I'm sure you'll figure out and get comfortable with how to do it because it's just a matter of substituting the values into this awful looking equation. But it's really not that bad. So just substitute them in, crunch it out, you get your answer. Now, we can use the savings plan formula to determine the amount we would need to deposit monthly in order to reach a specified or particular goal. So, at age 35, you start saving for retirement. If your investment plan pays an annual percentage rate of 6% and you want to have $2 million when you retire in 30 years, how much should you deposit monthly? So the first thing I would do is I would have looked in my phone for the formula. And then I would start substituting those values in there, and let's see what we come up with. Go ahead. Of course, you're doing stop and start. Okay, so 2 million is equal to the payment times, and here's all the numbers crunched. It's 6% annually, and you're going to do 12 payments in a year, right? Yeah, deposit monthly, so 12 payments in a year. 30 years, it's going to be in there. So I crunch all the numbers, substituting them in. I get 2 million equals the payment times this number, which is 2 million is the payment times this number. All it is 5.02257 divided by 0.005. And then when I do the division, it would have to be a little under $2,000 a month. And that kind of makes sense because you want $2 million and you're going to do it for 30 years. So it's a significant amount of money. If you could check your answer, if you turn around and put the 1991 back into the formula and see that you come out with 2 million in the end. Okay, so we'll start with total return in just a minute.